distributions, right?
Okay.
Probability distributions, then you'll need to then sort of book another session for normal distribution and yeah, continuous variables, normal distribution, and so forth. Okay.
Okay.
Because we only have an hour. So for an hour, I can do with you probability distributions, your Poisson, binomial distribution, hypergeometric distribution, and so forth. Okay.
Okay, sir.
Right. Cool. Let me just share some questions. I want to share my screen. Okay.
Okay.
Let me share my screen. All right. Downloads desktop. Okay. 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 All right, let me know if you can see my screen.
Yeah, I can see it.
All right, cool. Okay, maybe let me, because I wanna wait. Maybe do like this rather. Sorry about that. I'm trying to create a document that we can write on.
Okay.
Right. Downloads. All right, cool. Can you see it?
Yes, I can.
All right. So chapter 4 is based on discrete variables, Mpo. So discrete variables are variables which are countable, right? So they are finite. You know where they, where the variable starts when you count the variable and where it's end, right? For example, if you look at the number of parking bays at a mall, right? You know that maybe there are 20 parking bays, or just you guys in class, right? You know that there may be like 20 students who registered for your stats module. Okay, so that's a discrete variable, right? So chapter 4 is based on those type of variables. Now, what do you need to understand under discrete variables? Let me just quickly right? The thing that you need to know under discrete variables, right? You need to
Yes, sir.
understand that firstly, if you're talking about a probability is a value between 0 and 1, right?
Okay.
Right. Another
Yes.
thing, yeah, another thing that you might need to understand is that if you're talking about discrete variables, right? Discrete
Yeah.
variables will have sort of distinguish labeling, right? Like your parking bays, you'll have parking one. Let's say
Yes.
there are 5 parking bays, right? You'll have
Yeah.
parking 2, you'll have parking 3, then you'll have parking 4 and 5, right?
Mm.
So these are your parking bays. There are 5. This is an example. What you need to understand then under discrete variables is that for someone to park within this probability, it's a different probability from someone to park at parking bay 2, right? So each discrete variable will have a different probability of it being of success. Okay,
Okay. Okay.
right?
Mm-hmm.
Um, but if you sum all these probabilities which are different, right, you
Yes.
should have 1, right? Why? It's because you need, I mean, if the probability is equals to 1, it means that in any circumstance, that particular outcome will occur, right?
Okay.
If probability is equals to 1. So in any case, so the reason these probabilities are summing up to 1, it's because in any given case, you will have to park in one of these bay, whether
Yeah.
you're parking at 1, 2, 3, 4, and 5. That's why if you sum all these probabilities, it's equals to 1, right? All right.
Okay.
Then you need to understand that for you to be able to calculate a mean or an average out of these probabilities, you need to know that the formula to use is the summation of
It's
xi multiplied by the probability of xi is equals to x, right? This formula is for what?
for
Calculating
me. Mean.
mean, mean or average,
Okay.
right? I'll also give you a formula sheet, okay?
All right. All right.
That will help you understand these formulas, because my handwriting might not be like as clear as I'd want to.
Mm-hmm.
Right. So how do you then calculate the variance? To calculate the variance under discrete variables, you need to understand is the summation of. So what do I mean about summation? I mean you adding,
Add
right?
all of them. Yes.
Yes, yes, perfect. So it's the summation of xi all squared, right, times the probability of xi equals to x close bracket minus your mean, right?
Mm.
Which is
Okay.
this one here.
Yeah.
Minus, I'm just gonna call it m, okay?
All right.
So m all squared. So this is how you calculate your variance. Now,
Okay.
quickly, let's look at questions which are just based on this understanding of basic statistics of discrete variables, right?
Yes, please. Because really the questions are the ones that confusing me. I don't know which formulas to use for which question.
Okay, cool.
Yes. Mm-hmm.
Sorry. I know this can get confusing at
Yeah,
times.
yeah. The subject is nice. It's easy, but the formulas, they are confusing.
Yeah, they can be confusing. Basic statistics, right? Under discrete variables. Right, let's look at some questions now. Okay, right. So if you look here, so if ever you're given something like this, can you see my screen? I'm showing questions now. Can you see
Yes,
it?
yes, I
All
can.
right,
Yes,
cool. So if you look here, you've got this table that we've just spoke about, right?
yes,
Where
yeah,
you've got discrete variables starting from 0 to 4, right? Within
yes,
these discrete variables, you have probabilities of success, right?
able.
Okay, cool. Then um, these probabilities of success are called the PDF, probability density function, right?
Okay,
These are called PDF. These are called PDF, probability density function, right?
okay,
Now, what is the question now? What is the constructor's expected total profit this month? For the fact that they want you to find the expected, it means they want you to find the expectation, right?
yes,
For you to able, expectation is like your average, right? So if I'm asking you expectation of X is the same as the summation of
yes,
xi times the probability of
XI.
xi,
Okay,
yeah.
okay,
Now, how are you going to do that? So let's read the question. A landscape constructor bids on a job where he can make 3,000 profit per job, right? Per job.
yes,
So every job this guy does, he gets
that's
3,000
3,000.
profits, right?
Yes,
Let X denote the number of jobs that he bids on this month. The PDF for right PDF probability density function as is shown below. What is the expectation? So this is the formula you will use, right?
okay, yeah. So
So now do that for me. So this is saying 0 multiplied by 0.1 plus 1 multiplied by 0.1 plus 2 multiplied by 0.3 plus and so forth, right? If you do
yes,
that, what's your answer?
okay, let me do it. Just opening the
Yes, I'm also
detail.
doing it on my side.
Okay, it will be 0 times 0.1. Yes, so
Are you getting 2.3 as well?
yeah, I'm still multiplying. So
All right, cool.
times 0.8, 3 times 0.4 plus 4 times. The answer that I'm getting is 1.9. Oh, I made a mistake. 0.1. No, it's 2.3.
Was 2.3. Cool. Now
Yeah.
that 2.3 is the number of jobs this guy is expected to get, right? Out of bidding for all these 4 jobs, right? For all these
Mhm.
years. yeah, 4 jobs. Then we said that per job, this guy gets about 3,000 profits. So we need to multiply these 2.3 jobs he might get with the profits that he gets per job, right? So the correct answer will then be 6,900 rand.
Yes, 6.9.
All right, cool. Now let's look at this one now, right? Consider the CDF, right? What is the CDF? The CDF is called the cumulative distribution function, right?
Yes.
Now, how do you see what's the difference between these two, right? Is that if you're given a CDF, CDF means cumulative. So this is a probability where you're looking at cumulative probabilities. If
Okay.
you see that the last variable has a 1, it means that you are given a CDF, a cumulative distribution function. If the last variable is not equals to 1, it means you're given a PDF, right?
So that's how we distinguish them.
So
For
yes,
CDF, the last function, the last value will be 1.
for CDF, yes.
Always say.
Yes.
Okay.
So you know then I'm given a CDF, not a PDF, right?
Yeah. Yes.
All right, cool. So possible values for C and K are, so for you to be able to find these possible values, you need to sort of understand that the value of this one, you need to find the value of this one first, the C, right?
Yes.
Okay, so how does the CDF works, my dear Mpo, is that the probability of X less than or equals to 0 is equals to the probability of X is equals to 0, right? In this
Yes.
case, because there is nothing which is on this side of 0, right? So everything starts from 0, okay?
Yes.
So what does this mean? It means that our probability of, so I'm trying to convert this to become a PDF to find the value of C,
Okay.
right?
Yes.
Okay, cool. So the probability of X is equals to, the probability of X is equals to, then of 0 is equals to 0.1, right?
Yes.
Then the probability of X being equals to 2 less than or equals to 2. So this probability
This one. Yes.
should be equals to probability of X is equals to 0 plus probability of X is equals to what? 2,
2. Okay. Yeah. This 2.
right?
Yes.
So this is equals to C. You don't have. You have 0.1 plus the probability of X is equals to 2, which you also don't have, right?
Yes.
The probability, I'm trying to take you through step by step of how you can find C, okay?
Yes.
The probability of X less than or equals to 4 now will be equal to what, Mpo? Is equal to the probability of,
Probability of X being equal to 0 plus P.
right?
Yeah.
You can just maybe put it like this, is the same as the probability of 2 plus the probability of x less than or equals to 0, right?
So
If
for
you so cumulative means adding up, right? So for
yes,
you to find this value, that means you added this value plus this value to get this
to
value,
get that value, okay.
right?
Yes,
So then if 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 you added two values, then that means it's 0.36 is equals to 0.1
plus
plus
C.
C. Then what is your value of C then, Mpo?
It's 0.36 minus 0.1. 0.36 minus 0.64.
What did you get there?
0.36 minus 0.1. It's let me 0.26.
0.26, okay.
Mm,
0.26, right?
yes.
Then you have this value now. For you to find this value, that means you added everything from here.
That is 3 values.
You added these 3 values to get this value,
Yes.
right? So you do the same thing. You find the value of K. Then once you have that, for you to check, you need to take both these values, you put it in here. When you add all these values, you should sum up to 1.
Yes. Okay.
Right. I'll give you like a nice solutions for you to look through yourself. Okay.
Okay, sir.
Yeah. Okay, let's look at this last one, then we go to other distributions. So you also have this, they want you to find the average. You try this one out now. What do? You give in a PDF. For
Yeah.
you to find the average is the summation of xi times the probability.
Yes.
Right.
So yeah. This one. Can I multiply them? Can I do it?
Yes, please do it and tell me the answer. Then we go to other
Okay.
distributions.
Okay. Yeah, and 3, 4. It's 1.84.
1.84, okay.
Yeah.
1.84.
Yes.
So 0 multiplied by 0.07 plus
1 multiplied by 0.34.
1.34 plus 2 multiplied by 0.31 plus 3 multiplied by 0.22
Oh, it's
plus
1.86. So
oh, okay.
yes,
Yeah,
yes.
you need to be really precise, eh?
It's just that I'm using my cell phone calculator. So yeah,
Oh, that's
yeah,
why.
yeah. But I'll get them right with the proper calculator. Don't worry, sir.
Okay, cool. So now we've done some basic understanding of probability distributions on discrete variables. Okay.
Yes. So
Now,
for discrete variables, we always use PDF and CDF.
yes,
Okay. Okay. Yeah, now
right.
I
I'll
get
give you questions to do like as your exercise.
it.
Then, if you have any questions, then I'll then attend to them maybe on WhatsApp. Okay.
Okay.
Yeah. Right. So now I'm just erasing this because I want us to look at probability distributions. Do you know a dime, Paul? Dice.
Yes, yes. 1 to 6.
1 to 6, all right. What is the probability of getting a 1 out of throwing a die?
The probability of getting 1,
Yes.
isn't it 1/6?
Okay, cool.
Yes.
That's fair.
Am I,
That's fine.
am I correct?
Yeah, you're correct. Yeah.
Out of 6 chances, you can get 1. Like
Yes.
there's 6
There's only
chances.
one, and you can only
Yeah.
get it. Yeah. That's. I love your interpretation of it. That's good. Um. Then, what is the probability of getting a 6 now?
It's 1.
What?
Isn't it 1? The probability of getting 6 is 6 out of. It can't be 6 out of 6. So,
Hmm?
isn't it 1? Because that's the maximum value of a die.
Do you understand what one mean? One means that you saying to me, it's at every given time you throw a die, you get a 6.
Oh, that's what it means. Should to
Yeah.
get for me to get a 6, will it be um
It's still one
one
over
of
6, simple.
so for each and every value on a die,
Yes.
the probability is 1/6.
Yes. And do you understand? If you have a die, the probability of you getting a 6 is the same as the probability of you getting a 2 or a 1.
Oh yeah, because it only appears once, like it's only on one side of a die.
Yes.
So
Okay.
yeah, okay, I understand. Yeah.
So it's 1 over 6, right?
Yeah.
And so there are 6 sides. Say to me 1 over 6 multiplied by 6.
Is it one?
Multiplied by
It's
6
one.
is
It's
1,
one.
right?
Mm.
So if you have a die, have you ever hold a die before? A dice.
Yes. Yes.
If you toss it, have you ever had an instance where you don't have an outcome? So you toss it, you don't find a 1, a 2, a 3, or a 6. Have you
No,
ever, you've
there's
never had
no,
that experience, ne?
no. Mm-mm.
All right. So if you look at these 1 over 6, so every discrete variable, firstly, the die has discrete variable outcomes. You know they start from 1 to 6. Okay?
Yes. Mm.
All right. So they're countable.
Yes.
Okay. Then I'm saying for you to get a 4, it's still 1 over 6. A 5 is still 1 over
One
6.
over 6.
A 6 is still 1 over 6, right?
Yes.
If you add, so add 1 over 6 times for me, what do you get?
Okay. 1/6. Isn't it the same as multiplying by by 6?
Yes, it's the same.
So
Okay, so what do you
it's
get?
1.
1. All right. So what does this mean then? The 1 means that at any given chance you throw a die, you'll get either 1, 2, 3, 4, 5, or a 6. This 1 means that, right? And it
Okay.
still holds that for every discrete variable, if you sum all the probability of success, it should add up to 1.
Yes.
Okay?
Yes.
Now, if you have a situation where the probability of success of each and every variable within your sample space or your discrete variables is the same, you need to understand that you're dealing with a case which is discrete, fine, but it is known as a binomial distributed case.
Okay. Binomial.
Binom. I'm just gonna call it binom, right?
Yes.
Dist. This means binomial distribution,
Distribution.
right? So let me just maybe rephrase this. If you have a situation where it is discrete and the probability of success for each variable within your discrete variables is the same, you need to understand that your data is binomially distributed, right?
Okay, sir.
All right, cool. Now, what you then need to understand under binomial distribution is that um, the expectation or the average or the mean is calculated as just NP, right?
And
The
yes, sir.
variance is calculated as just NPQ, right?
Yes, sir.
Then where Q is equals to 1 minus P, right?
Hmm.
And the probability density function, the PDF of binomial distribution is equals to the combination of your sample size, which is discrete, probability of success raised to your xi, open bracket, 1 minus P, which is the same as Q, N minus Xi. This is the PDF, right?
Yes.
Right.
Mm-hmm.
So under binomial distributions, your questions will come within these formulas, right? You need to understand you might be asked a question based on inequality.
Mm-hmm. Inequality.
Inequality. So this is where you're looking at your greater than, less than, greater or equals to, less than or equals to, right?
Yes.
Okay. Or else you're gonna be asked a question based on equality.
Okay.
Okay.
Yes, sir.
If you ask the question based on equality, we'll use this PDF to find the answer. If you ask the question based on inequality, we'll use tables.
So we use this formula in a table.
Sorry?
So we use this equation and the tables.
So if we ask the question based, we'll look at the questions just now, right? If we
Okay.
ask a question based on equality, I'll show you how it's based on equality. We'll use this formula. If the question is based on inequality, we'll use this formula. We'll use the table, right? The statistical tables. Do you have, I think I did share the statistical table with
Yes.
you guys, right? All right, cool. So please open also that. Yeah, right. Now, before we go into that, let me teach you something just real quickly. Where is this thing? Right. Can you see my screen? I'm showing
Yes.
wording.
Yes, I can.
All right. So I'm asking you now, Mpo, if someone comes to you and say, Mpo, can you please borrow me at least 6 rand? How much would you give that person?
Well, at least means it will be 6 or more, I think. So maybe 7 rands or 8 rands going up,
All
because at
right.
least, yeah.
All right. All right. All right. So you'll give this person 6 rand and above.
Yes.
All right. Cool. Then if someone asks you, can you please borrow me more than 6 rand? How much would you give that person?
Then we won't include 6 when the person says borrow me more than 6 rand. We'll start
All
at
right.
7 rand.
So we
Yes.
understand that that's just greater than, this is greater than and equals to.
Yes. Yes. Yeah, I understand.
All right, cool. Then if someone says, can you borrow me Mpo not less than 6 rand? How much are you giving this person?
Not less than.
Yeah,
Then I'll give him 6 rand.
not less than 6 rand.
Not less means 6 or more, say.
6 or more, yes. So it's greater or equals to. Okay.
Yes. Yes.
At most, can you borrow me at most 6 rand?
At most, is it less?
So the maximum amount they want is 6 rand. That means they want less than or equals to 6 rand. Okay.
Oh, okay. So at most is okay. Yeah, I see.
All right. So
Yeah.
less than 6 rand.
It's 5 from 5 rand going down. It's less.
Okay. 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 So, all right. So no more than 6 rand.
No more than 6 rand, isn't it less than 6? It's less, it's
Yes.
6. Yeah.
So it's less than or equals to, right?
Yes.
Can you borrow me the money between 6 rand and 10 rand? So it's 7 and 9 rand.
It's between 6
And
and
10.
10. It's
So it
7,
means
8,
I
9.
want anything which is
Between
between 10 rand and 6 rand,
6
not
rand
including the 10 rand and the 6 rand,
and the 6. Okay.
right?
Mm.
From, can you borrow me from 6 rand to 10 rand? I want you to include 6 rand to 10 rand.
Yes.
All
So
right.
between we don't include them, but then okay. Yeah,
Yeah.
I understand.
Right. So now let's look at questions here. Look at this. Read here for me, Mpo.
70% of motorists who park at ShopRite don't display a parking disc on their car. Parking disc is a proof that the motorist has paid for parking his car at ShopRite. A sample of 20 vehicles that parked at ShopRite was randomly selected.
Okay. All right. So 70%, this is the same as 0.7, right?
Yes.
Right? So 0.7. And you give in your n as what?
20.
20. So what does this mean? Out of these 20 variables, right, which are discrete 1 to 20, the probability of success of is of these variables being of occurrence is 0.7, right?
Yes.
It means that all these 20 variables have the same probability of success, which is 0.7. And we both agree that once you're in a situation of that sense, you are dealing with binomial
Binomial
distribution.
discrete. Yeah.
right? All right,
Yes,
now
sir.
let's look at questions. What is the probability that at most half of the vehicles in this sample does not display a parking disc?
Yeah, I see the at most half of the vehicles. Okay. 10.
Right? So
Yes.
at most, what does it at most mean?
It means it's 10 or less. I mean 20 or less.
At most, right?
Eh,
It's less than or equals to, right?
mm,
Half, at most half. What is half of
it's
20?
10. It's 10.
Now I'm being asked a question based on inequality. What do I need to use? Tables.
The tables.
Uh, tables. Okay, let me try get nice tables. I think I did have, say, tables. Where are my tables now?
I'm searching for mine also. Okay.
All right, please search for yours also.
Expressions. Do we use the standard normal table?
No. I'll show you just now. Just give me a second. I'm still
Okay.
looking for my tables as well.
Okay, sir.
Right. Standard normal tables are for continuous variables. You're dealing with discrete variables, okay?
For now, okay, sir.
Yeah. Oh, there's something it's tables. We have these tables now. What's up? I'll find them just now.
Okay, sir.
Right. Right. Tables. Just imagine I sent you guys this. That is the. Have you found yours?
No, I haven't. What did you leave them here on the thing on the Teams thing when we met or for Saturday
Yes,
classes?
I think I did, but I'll send it to you just now also, okay?
Okay, so
I'll send to you because I found mine now.
okay.
right, so let me go downloads. All statistical tables, open file location. Just imagine. Right, so these are the tables, right? Can you see them?
Yes, I can.
Right, cool. Look here. This is the PDF for
Mm.
binomial distribution, right?
Mhm.
When do you use these tables? You only use these tables if you ask a question based on binomial distribution and it's based on inequality. The question is based on inequality, at most, greater than, less than. Those are inequalities, okay?
Yes.
Right? Your sample size is 10, right?
Yeah.
From the question. No, your sample size is 20.
It's 20, but then, yeah, the question was asking about half.
Yes, it's 20. The question is based on 10, right?
Mm.
Your probability of success is what? 0.7.
Yes.
Where is 0.7? It's
Okay.
here, right?
Yes.
So this is your answer.
0.0480.
0.0480, 0.0, this one.
Yeah, B. It's B.
Right.
So for this one, you just check the table and you get your answer.
Yes. Because
Okay.
it was a question based on inequality. If this is not here, let's just say they did not say at most, they said, what is the probability that half, so this is not here, right?
Uh-huh.
What is the probability that half of the vehicles in the sample does not display parking disc? Then this question is not based on inequality. It's based on equality, right?
Yes.
If it's based on equality, you use the PDF. You use the formula. Where is this formula now? You use this formula, right?
Okay.
So you have your N, which is 20, your X is 10. This is combination. So in your calculator, what type of calculator do you have?
It's a scientific one.
A Casio or a Sharp?
It's a cash.
All right. So in your Casio, you need to say 20, shift, you press the division sign for the combination, right? So this is what will appear in your screen, in your Casio calculator. 20C, then 10, right?
Yes, sir.
This means that 20 combination 10 multiplied by your probability of success, which is 0.7, all raised to your X, which is 10, multiplied by 1 minus 0.7, close your bracket, then into raised to 10 minus your X, which is 10, right?
Yes.
So then you'll get your answer. The answer you'll get a probability of at any given time at these parking bays, you find that 10 cars don't have parking disc, right?
Yes.
I only use that formula if I'm being asked a question based on equality. Otherwise, I go straight to the tables, right?
Okay, sir.
Right. Now, this is another question based on this information given. Each vehicle does not display a parking disc will pay a parking fine of 450. What is the total value of the fines that you can be expected to be handed out for this sample? Expectation, right? You want to find the expectation. You're dealing with binomial distribution. To find the expectation under binomial distribution, what you do is n multiplied by
N multiply, yeah, it's NP.
Right? What is your sample size? Is 20.
Sample size is 20.
What is your probability of success, Mpo?
For all of them. Or
Yes.
0.7.
All right. What is the answer you're getting here? So 20 multiplied by 0.7 is equals to what?
It's 14.
It's 14.
Yes.
So then what is 14 multiplied by 450?
14 by 450. It's 6.3.
So this is the amount of fine you'd expect to get out of this sample, right? 14 cars out of 20 cars, you'd expect them to not have parking disc, right? Now, if 14 cars don't have parking disc, it means that you can collect about 6,300 a day, right?
Yes.
Now let's look at another distribution. We've looked at binomial distribution. Now let's look at another distribution called Poisson distribution.
Yes, please. Poisson.
So far, so good.
Yes, yes.
You see, these things are easy to understand. You just need to give yourself time, go through some questions, you know?
Yes, yes, true.
Or is it how I explain these things?
I think it's how you explain them. You explain them like you make them easy, say. Because I had a class for this subject on Mondays. I used to attend, and it's done by one of, I think it's Miss May.
Okay.
She's also good, but I don't know. Maybe I understand you better.
Okay, cool. No problem. As long as I'm still around, you guys can request one-on-one sessions. Then I'll take you like step by step to understanding these things, right? So I'm just trying to erase. I'm just trying to erase here. Okay. Now, there is something called count data, right? Count data is a type of data that is sort of observational data, right?
Yes.
Let's say, for instance, you own a garage, petrol station garage, right?
Yes.
So out of your garage, you're interested in to just understand how many cars you get or come to your garage per hour, right? Then we will say maybe 20 cars. You get 20 cars, right? For an hour. For 1 hour. Right?
Yes.
Now, for you to see these cars, what did you do? So you were just standing on your beautiful garage outside of it. Then you counted these cars coming in an hour, right?
Yes.
Then we talk of count data. Which is also discrete, right? You can't count a car and say, this is 1.3 car that comes in, right? You count them as whole numbers. You count them as finite. They are countable. They are discrete, right? Now, Mpo, you can never be exact. In today's hour, you got 20 cars. Maybe tomorrow you might get 18 cars in an
Yeah.
hour. Maybe the other time you can get 23 cars, right? Maybe on Friday you then get another 20 cars in an hour, right?
Yeah.
Now, this 20 will then be referred as an average. So on average in an hour, you get 20 cars. What
20.
does it mean? It means that in any given time, I know that I'm expecting at least 20 cars in my garage in an hour,
Yes.
right? It
Yes.
means that average, orange. Average is the same thing as X bar, right?
Yes, me. Yes.
Which is your sample mean. This is a test statistic. It's a statistic for a parameter of population mean, right?
Yes.
So if you have something like this, then you need to understand you're dealing with Poisson distribution, right? Count data, you've got your average, you're given your average in some way or another. This average you given is constrained in some time interval or whatever interval, right? So what
Yes.
I mean is you'll be given an average. This average will be constrained in some sort of an interval. So this is true if this is true, right? So in this case, you will have 20 cars coming in, right?
Yes.
Other questions may be like, okay, you'll get 20 cars in 3 days. So this is true in 3 days. This is true in, you get what I mean. So
Yes.
the
Yes.
question
Understand.
will give you an average and will give you a constraint for that average, right? Poisson
Yes.
distribution. Now, if ever you're being asked a question based on inequality and you're dealing with a question which is Poisson distribution, what do you use?
If you are given what, sir? Sorry.
If you're given a question based on inequality
Yes.
and you're dealing with a question which is Poisson distribution, what do you use? Tables,
The
right?
tables, because inequality. Yes, sir.
Yes,
Inequality.
tables. If a question is based on equality, you use the PDF.
Yeah. Formula. Yes.
Now let's write the formula for Poisson. Xi
Xi.
is equals to X, open bracket. I think it's E minus your mu Xi.
Mu times xi.
Uh, wait. Right.
Oh,
So
I have it. I have it.
yeah, I think here.
Yeah, it's x equals to e exponent negative mu. Is it that one, sir?
Yes, it's that one.
Yeah,
Did you
over
write
mu
it
exponent.
correctly?
Yeah, yeah, and not the one that we're talking about now, but the one that I had. Yeah,
So
it's
it's E
in here.
raised to what?
Negative mu
Yes, and
multiply by mu exponent x all
okay, cool.
over.
Cool. I
Yeah,
wanted that. I wanted that. Multiplied by mu
exponent x.
xi.
Mm-hmm.
Yes, so this is the PDF for Poisson distribution, probability density function for Poisson distribution. If you're being asked the expectation or the average under Poisson distribution, you need to understand it's the mu that you're given,
Okay.
right?
Mm-hmm.
And this is the same as the variance.
Okay. So the mu is the same as the variance.
Yes.
Okay.
Let's look at some questions now. This is the,
your screen. I can't see your screen now, sir.
you can't see it, really?
No, no.
All right, give me a second. All this time you were seeing it though, right?
Yes, I was.
Can you see it now?
Yeah, I can, sir.
All right, so you've got this, the average number of lions per day, right? Per day at a safari is 5. Okay, so that means 5 is for what? 1 day,
Okay. Yes.
right?
Evo.
Now, just from this information, I can see that I'm given a question which would be based on Poisson distribution
Poisson.
because I'm given count data, which is also referred as observational data. Then from that data, I'm given an average and I'm given a constraint of this average, right? I'm being told that 5 lions you can only see in a day,
In
right?
a day. Yes.
Then the question is, what is the probability that the tourist will see fewer, right? What does fewer mean? Can you borrow
Fewer
me,
than.
right?
It's le, yes, sir.
Then 4, right?
It's less than 4 years.
This is the same as what? Probability of x less than equals to 3, right? If you say, give me money fewer than 4 rand, that means I want 3 rand and less, right?
Yes.
Cool. Now, this is a question based on inequality. What do I use?
You use the table.
All right, let's go to the tables. Now, let's go to the tables. All right, let's go to the tables. So, Poisson distribution, right? What is your average? The average you given is 5.
It's 5.
Right?
Yes.
There is 5. Fewer than 4 is 3, right?
Yes.
So this is your answer. Right.
265.
265. 265. So this is your answer.
Yeah. C.
Right.
Okay.
So yeah, that's it for that's your probability distributions. That's your chapter 4. I'll now give you let me see if I can just give you now before we end the session. Let me see if I can give you the stat tables.
Please, sir.
Create a link to share. Right. So these are your tables. Now, let me also give you this exercise, these questions, right? To just go
Yes,
through,
I'll do them.
yeah, go through them. Right, all right, all right. Then
So, the assignments of this course, are they not timed?
I don't know. I really don't know. But you can ask Bulelwa that. I'm not sure. If you guys, you haven't written any assignments.
We have written one, but it was just 10 questions. So I wouldn't say it wasn't that hard. I think it was
When are you
just
writing
focusing
another
on
one?
after this one, because this one closes on the 17th of May.
Oh, okay.
Yeah, so I've seen these questions that we were doing with you. So I'm just not sure if it's the exam question papers or the assignment questions. So I just need to
Oh,
know if
okay. No, I really don't know. If you want to ask me anything, I'll leave my number to the chat, right?
Okay, sir. Okay.
All right, that's cool then. So please also send me the what is
The
this?
recording.
The recording. Yeah, please send me that. Use WeTransfer because it's gonna be, there's something called WeTransfer, so you need WeTransfer, right? So
Is
use
it
that. So on Google you go WeTransfer, then you send it through WeTransfer the
okay, sir.
recording, because
Okay.
I'm not sure if you're gonna be able to send it through an email because it's gonna be a huge file.
Yeah, I'll check that with transfer thingy.
Yeah, check WeTransfer. All right then. Thank you for your one-on-one session. Hopefully you request another one for chapter 5, which is based on normal distribution. Otherwise, you can always text me.
Okay. Yeah, I'll do that, sir. Thank you very much.
All right, Mpho, bye.
Thanks, bye.